Hey science lover, did you ever think how old Earth is? Some of you might know about the number 4.54 billion years. But did you ever think how this number has come into existence? Is it written in any holy books or is it just a random number given to the world? Welcome everyone. Today we're gonna talk about the journey of this number. It was not as easy as you think. It took centuries to give an acceptable number. And the whole idea starts with the Scottish geologist James Hutton, who transformed our concept of the Earth and the universe by reading the message carried by the common rocks. In the year 1830, after the first volume of Charles Lyell's Principles of Geology, almost all geologists agreed that the Earth was immensely old. But how old? The problem was a hard one. At that time, the most common method was to add up the maximum thickness of all the sedimentary rocks on the Earth and calculate how long it would take to deposit those layers and use the minimum age. In other words, first they assumed a fixed rate of sediment accumulation. Now they start looking around the world and find out the rocks that have maximum thickness for a particular period of time and then give a number for the age of the Earth. Most such estimates comes to about 100 million years, which we now know is off by a factor of almost 50. What was the reason behind this wrong number 100 million years? One of the reasons was the given rate of sediment accumulation. Moreover, the biggest problem was that they did not account for erosional gaps in the record, which is known as unconformity. Unconformity forms when there is a no rock representing a time interval. Later studies have shown that rock record is full of time gaps and is actually more gaps than record. Some geologists at that time suspected that there might be a problem with unconformities, but no one could know how big a problem it really was. Then there was a famous estimate by Irish physicist Joly. After knowing the rate at which salt enters the ocean from the world's river, he tried to calculate how long it would take for the ocean to go from a fresh water to their current salinity. His estimates for the age of the Earth again comes to be around 80 to 100 million years, which we now know it is wrong. Again, the problem was his faulty assumptions. Joly assumes that the ocean has been constantly adding salt since they formed. But the truth is, salt content of the ocean does not change much through time. That is, seawater salinity is in equilibrium and stays very stable. Time passed on, and then the most famous and influential estimate was made by the renowned physicist William Thomson, who later known by his title Lord Kelvin. He was a great scientist of his time, and few people dared to disagree with him. In the year 1862, Lord Kelvin trying to solve the problem of the age of the Earth by using thermodynamics. He assumed that the Earth had started as a molten ball at the same temperature as the Sun, and that it had cooled off at the rate that we can measure from the heat coming up from the Earth's interior. From this method, Kelvin estimated the age of the Earth was only 20 million years old, which is much younger than the estimates presented by the others at that time. It was also a problem for Charles Darwin, who knew that the Earth had to be immensely old for his newly proposed concept of evolution to work. But the problem with the Kelvin's estimate was just like the others, faulty assumptions. Kelvin made his calculation of the cooling of the Earth by assuming that the heat was from the original solar system and no other heat source were involved. We now know that this is again wrong. The Earth does have an additional heat source. It's radioactivity. Did radioactivity only help in clearing the Kelvin's idea about the Earth's heat? Or it also helped in determining the exact age of the Earth? How the concept of radioactivity comes into play? Who are those scientists who devoted their lives for developing the concepts of radioactivity? We will discuss all this in the next video of radioactivity. If you like this video, please share with your loved ones and subscribe to the SCIDiaries for better understanding. Till then, stay tuned. Thank you.